Hello everyone, thank you for coming along tonight. Thank you for Red Hat for organising it. I know SAS puts a lot of effort into this. Thank you very much to the previous speakers for talking us through some of the good features in llm-d, vLLM, why we're here today, why we're using the software. I'm going to be talking a little bit about my experience in evaluating vLLM, eventually llm-d at one point in the future, when it was released I mean, and trying to take that into production, early sort of prototypes, giving customers early access, internal customers as well as external, sort of lessons learned there, what worked for us, maybe what, and by the way, what works for me maybe not, maybe doesn't work for everyone. So yeah, kick off with that. Who am I? Software engineer, system admin, network engineer, done most things at one point in time. Passionate technologist, open source developer, user, enthusiast. I was a Linux distro maintainer at one point in my life. Can still to this day, operating system development, one of my core passions, contributing where I can. I like problem solving, I like contributing back, that's why open source software is at the heart of most of what we do. We like to try and contribute back. We've got patches getting ready to be pushed back to the likes of Ceph, so on and so forth. Why are we here? State of the Union, sort of GPT 3.5 and GPT 4, igniting the AI boom in November 22, March of 23. These releases are very much tied to sort of large sort of investment cycles that kicked off with deployments of GPUs and everything else. AI demand, explosion from the early market, largely from model builders, frontier labs, initial supply largely from former crypto miners, and all the sort of hype and bias and everything that was pulled in, good and bad, one way or another, from the cloud computing world and high performance computing world. Early market geographic location largely does not matter. This is again somewhat relevant to why we're talking about inference today and why llm-d with distributed inference does matter, because it goes beyond a single site. The initial supply, again, not even necessarily cloud, it's mainly just handing over the keys to the assets and letting the frontier lab have at it. But the changing demand and dynamics that we're now seeing in the market are quite interesting. Model builders and the frontier labs continue building. Other people, most people in this room I guess, who's using open source models today? I certainly am. Good, raise the hands. It's a big, big difference from where it was 3 years ago in the early market, so very happy that we've got open source quality models available to us. More importantly, all of a sudden, things like geographic location does matter. So that provides an interesting sort of starting point. vLLM, again, I assume everybody here knows what vLLM is. Hands up if you're using it or have used it. Fantastic. Large percentage of the audience. Largely, the sort of main important points for me, it started out live at Sky Computing Lab, UC Berkeley in California. Lots of, say, UC Berkeley got a wonderful track record producing quality software going back to the days of being DARPA funded and doing lots there. BSD, Unix came out of there. It's grown into quite an active open source project, maintained by quite a diverse community as well. I think everyone's well aware of the sort of problems of open source in the past, where you've got one project that's got like rigid maintainers that never change, and if you happen to not agree with that, you might not be able to sort of bend it to your shape and end up with the depth of carrying patch sets, which everyone tries to avoid these days. Main points about it, it's quite easy to use, open source models. These features here, really good innovations. The paged attention, basically bringing the operating system sort of paged memory model to language models, which was a good thing. More importantly, I think the compatibility side of things cannot be emphasized enough. Basically being API compatible with OpenAI and the Anthropic messages. Just, again, if you want to be considered to be compatible with as many people as possible, and more often than not, you'll be used. The wide range of hardware support, really good as well. I started out in the early market. I had a complete mishmash of GPUs, largely sort of 50-50 split between AMD and NVIDIA left over from the crypto mining business that I was the parent company of my startup. And that's where I first started looking at things. I mean, this was pre-NVIDIA Dynamo, didn't exist on the market at the time, so really early in trying to get an idea of what could work for me. Who needs vLLM, more importantly? I'd say any organizational developer who requires the ability to serve models, whether you need that from a privacy perspective, whether you're providing model as a service to customers, whether you're building sort of user-facing applications that depend on models. There's a myriad of reasons why you may or may not require it. I'd assume everybody here requires it in one way, shape or form. Early investigations. This was after I came into Stelia. So a bit of a background on Stelia. It's relevant to this discussion. Stelia started off life as being focused on network connectivity in the early days of the AI sort of boom, providing connectivity service to lots of the little GPU neoclouds. Hands up if you're aware of what a neocloud is. A lot of people aren't. Good amount of the audience, neocloud for all intent and purposes are startups that are providing large clusters of GPUs, normally leasing them wholesale to hyperscalers or making them available to the market publicly. But this gave Stelia sort of early insight into what the distributed geography of these assets could be, and you start to formulate lots of ideas about, oh, what if? Because we were always big believers in we can't just have a large single site, it's not going to work, there has to be geographic distribution. We've seen early models of that in cloud computing with availability zones, AWS doing great jobs with their API gateways for routing traffic and load balancing, so on and so forth. So yeah, we decided quite early on that whatever we used would be based on open source. We believed that was the path to good quality, and also allowed us to patch what maybe didn't work for us and contribute those patches back and helping the community where possible. We were quite happy with vLLM straight on. Again, quality piece of software, rich feature set, coming out of UC Berkeley. The sort of very active community around it gave us a lot of faith in what we could build on top of that. Again, vLLM on its own, inferencing engine, you're not expecting everything out of the box. We were not necessarily going to get high availability, all these things just immediately. The orchestration piece is not necessarily there. Missing the sort of diversity of having multiple clusters of GPUs available to you, and all. Again, multi-tenancy is another sort of consideration we were looking at. We were going to be providing this as a service both internally and externally to a wide range of sort of customers or users. And again, things like on the multi-tenancy side, quality of service, wanting to make sure that you've not got the noisy neighbor issue and all these different things. That sort of takes us back to why were we doing this? We were building, at this stage, had our own cloud infrastructure with the aim that we should be able to self-host and self-deliver. That took us to the point we need to be able to self-host vLLM, thus we need a way of having a vLLM service within the cloud infrastructure as a means of spinning this up and having the same outcome time and time again and having the reliability. And one of the main things that we've all come to sort of know and expect from cloud computing, elastic resources. So the early sort of testing we done with vLLM is very much looking at, if I set this up for a single consumer, I can just spin up a compute instance on the cloud infrastructure. We can do a bit of hand plumbing with vLLM and basically just expose it as a service. Then comes the high availability point. What could we do there? Okay, we need to start making use of shared storage, making sure we're not using any local storage or things that would tie us to specific instance, and it got to the stage where we decided, okay, we could spin up a few of these, basically treat them as stateless web services, have a little bit of load balancing in front of them, and see where we can get to. Heavy caveats, you're going to miss some requests. It's not pretty. It was functional for like a handful of users. But I think that was the good point. Starting simple and really considering what do we need from this right now? And actually trying to learn from what we were doing. Some people don't factor in lessons learned, which is interesting, but I digress. But, as I went back to what we were saying earlier, Stelia's origins were in sort of distributed networking, with a view of one day we would have distributed compute assets, different geographic locations, and we were always looking back thinking, how do we take this beyond a single site? We knew at that point, at that time, vLLM on its own was not going to be able to get us there. Even sitting looking back, could we start building out more network services and load balancing to try and help with that? What could we do? And again, it wasn't the right fit. And again, it wasn't designed for that, so it's designed as an inference engine on its own. ByteDance kindly open sourced AI bricks. I guess, again, maintained under the vLLM umbrella. The cloud native piece for hosting within Kubernetes, again, getting those pieces of auto-scaling, high availability, that started to sort of speak to us. Our cloud infrastructure built upon Kubernetes, albeit stripped back, and again, services, all or metrics, all that type of stuff, per tenant rather than per service. Similar to what the hyperscalers are doing with micro VMs, that type of thing, rather than containers, but still Kubernetes at its core. So something that we could host within Kubernetes was appealing to us. Some of the other pieces that we quite liked were the traffic management side of things. Again, that took us back to the multiple sites. And yeah, so caveat here, we evaluated AI bricks. We did not actually put it into production because we were still, again, at that small number of users. I think we probably spent, this would have been Q1, Q2 2025 with the initial sort of playing around with vLLM and evaluating AI bricks. Thankfully though, we didn't have to spend too much more time evaluating AI bricks. Talking more, I should have done that on this side, but yeah, vLLM, as I said, was good for us. We were able to try out hosting a handful of different compute instances, throwing a load balancer in front of it, kind of doing what we needed it to do internally, but again, sort of hand up, I couldn't stand in front of a board and say, yes, we can absolutely take this publicly and we won't miss anything and it'll work perfect. No, good enough for what it done. The iBricks piece, yeah, most boxes checked. A lot of the things it brought in was quite nice. Again, GPU utilization, especially from a QoS perspective, not wanting noisy neighbors to throttle GPUs. The KV cache side of things, the routing, we were all happy with that. Despite the fact that it's not a full-fledged multi-tenant platform, it's not what it was developed as. It was developed by ByteDance specifically for what ByteDance needed to do. I feel personally it was far more focused on sort of model operations and the life cycle of a deployment. It wasn't, again, a sort of public compute platform. One of the big things was the multi-tenancy topic, not just from a quality of service perspective, but because we may have offered that publicly at some point, we put a lot of focus on tenant isolation from a security perspective. We follow the same sort of principles as the hyperscalers, using the virtual machine as the boundary between tenants. Trying not to have things like shared API keys between tenants. One of the issues we found with AI bricks was there was a bit of discussion on how to handle the shared API key topic. I don't think there was necessarily an agreement on the best path forward because the discussion sort of spanned multiple tickets in the issue tracker. I gave a bit of consideration into could we develop this, but again, where we came back to time and time again was if the maintainers at this point in time are not in agreement on how to do it, could be futile, me even spending time with development resources on it. And this took me to the point of where llm-d was coming in. And I do want to highlight at the bottom, none of the above means any of this is bad software, just designed for different use case. You probably have a different use case from me, not many people do. If I was just building an internal model garden for a company, whatever, I would just stick probably vLLM handful of compute instances, a little bit of lazy load balancing on it, and call it a day. Least amount of effort for the most bit of reward. I'm a software engineer, most of us are lazy. llm-d, I alluded to this being released in, I think it was Q2 2025, correct me if I'm wrong there. This immediately caught attention of us because it spoke to the distributed nature of our business, and it really seemed to solve a lot of the problems that we had. Most importantly for us, it checked many boxes. Open source from the get-go, again, big thing for us. Cloud native, fairly immature at the time, but backing by Red Hat is, again, inspires confidence. Went back to saying that at the beginning. We've all looked at open source projects, thought, can I use this in production? I don't know if the trust is there. The more important thing for us was, though, again, the distributed nature, inference scheduling, the routing piece, and the efficiency of everything. It spoke to doing that more than being a control plane like AI bricks. So again, sort of having a firm boundary on what llm-d done and what was left to vLLM, which was good. Again, Unix philosophy, do one thing, do it well. Again, going back to what I said, instead of being a stateless web service with a load balance in front of it and missing requests at certain points in time, it takes the approach of utilising a sort of inference-aware scheduler. What I really liked about this was definitely the quality of service issues being addressed there, but it gave me a lot of sort of confidence, especially when you start to look at the disaggregated prefill and everything else. Some of the concerns I had were around sort of KV cache and sort of cache misses. I mean, with all software engineers know the sort of pain of cache misses on CPU compute, GPU compute, not too dissimilar. Not apples to apples, but again, not too dissimilar. One of the things that I really liked about llm-d was the scheduling piece, even taking into consideration a cache miss, for example. It would also take into consideration GPU utilization at the time, so even if you would miss, or you would suffer a cache miss on one GPU, if it had a much lighter load on it than the other one where you wouldn't have a cache miss, it would still schedule to the one you'd accept the penalty of the cache miss, but at the end of the day, you're still on the GPU with the least sort of utilization. You can get off of that. The schedule, not just focusing on cache, was good as well. Took into consideration a lot of other things we looked at, especially sort of queue state and back-end pressure. I think, again, anyone that's developed, hands up, you can develop back-end systems for any sort of type of application, with heavy traffic especially. Back pressure, always a consideration, things like that. I felt AI bricks didn't necessarily factor that in much at the time. vLLM on its own, not really within the scope either. The big thing though was the feature delta over AI bricks, the disaggregated serving at the time as well. We went back to that time and time again of what do we need? Something that will work on multiple pools of compute. That could be different GPUs in different locations, especially as we start to consider what, again, distributed compute across geographic regions would look like, thinking maybe big, beefy, powerful clusters and sort of core data centers with lesser powerful GPUs in edge locations. Being able to schedule workloads in different clusters was of importance to us. Didn't have to work on day one, but at least having that as a priority of the project was important. Again, going back to could you have contributed to an AI bricks, potentially would have been accepted, I don't know. Same path forward. This goes back to exactly what I done, understanding what you were building and why. I used the example of an internal model garden. If you're just building an internal model garden for 5, 10, 15 users, and you've only got maybe 5 models, probably better off just sticking to vLLM on its own, spread it across a bunch of different compute instances, shared storage, lazy load balancing, and accept that for what I've invested, this is acceptable. Again, sort of think Hugging Face, but internally hosted. This is where it gets quite interesting, the shared platform piece, when you've got a load of different developer teams, or maybe you're selling this publicly and you've got customers across the board using this. This is where you start to get need for organization isolation, authentication, quotas, governance, quality of service issues, all these different things. Again, more what you're getting off the frontier labs and their models today. Sort of big lesson learned, don't skip an authentication, even in internal products. Sounds kind of obvious, but not really. Surprisingly, it's critical to know who's using which models and who's absolutely hammering the systems. You can then either give different departments within your company a bigger budget, or you can give people a telling off, or both. Observability, again, obvious but not obvious. That's something I would advise putting in as early as possible. You can't improve what you can't observe, despite what some people might claim. The sort of main sort of metadata you'd want to collect: requests, tokens, latency, especially the tenant. You've got some people that are heavy model users and absolutely hammer them, and the model itself. One of the big things I would say is, like any software project, try and narrow the scope as much as possible. You don't want to say that you're going to go out and deploy GPU compute resources across the globe from day one. At least having that as an understanding is good. But really where we started off was just saying, right, we need to start evaluating this for an inference service within our cloud platform. We can start out just providing this to internal use cases. And again, starting from vLLM on its own was a big learning experience for us, understanding actually what does this do, what doesn't it do. And that gives you a sort of stepping stone to thinking, what can I get out of, or what do I need to get out of the other service? And like anything, I like to evaluate and try before actually committing to something. That was the sort of experience with AI bricks. We spent quite a bit of resource actually just looking into it, interrogating, not really getting the feel that it was worth the whole is the juice worth the squeeze analogy. We didn't feel it was at that point in time for us. And if llm-d hadn't been released when it had, I don't know, maybe we would have used AI bricks, but we were quite thankful for the fact that llm-d was open sourced at that point in time. And again, depending on what you're building. Overall though, I just say rule out a lot of the advanced functionality if you are stripping back the scope. Today, you could probably start with llm-d, but I think it takes a bit of having a level of understanding around, am I going to have multiple compute clusters of different types of GPUs? If you do have that on day one, great, I'm happy, absolutely have at it with llm-d, but if you're starting off with a handful of GPUs in a workstation, like most people, you're probably best starting with vLLM to begin with. Also want to point out that llm-d does not replace vLLM, it makes use of it. Some people seem to have a weird concept of it. Because I put comparisons of vLLM, llm-d on there, previous presentation, someone came up and asked, or one person stated to me, you know it doesn't replace it, right? And I thought, okay, I better mention that in future. Someone else actually thought it did replace it, so it was interesting sort of audience engagement there. So that's our sort of path at the minute. We've learned that vLLM does exactly what we want it to do. It's absolutely the inference engine that we want to use. Making good use today, like all startups, many prototypes inevitably end up as production. I'm not opposed to the judicious shortcut. But we're now at the stage of taking that and starting to mold a sort of llm-d implementation within our infrastructure products. Very happy with what we've seen in the initial sort of testing, and I'd be very much looking forward to getting it into production. I'd say probably Q3, Q4 this year for some early testing. I expect to contribute patches back, which would be great. Yeah, questions? At it back.
Can you hear me?
I can hear you.
My name is Petrus. I'm an inference engineer at AI. So I just wanted to ask if you consider using NVIDIA Dynamo, since it's kind of like similar to like llm-d, and what were like the reasons why you didn't use NVIDIA Dynamo. So just want to see whether you compared llm-d with NVIDIA Dynamo and like what led you to use llm-d eventually.
NVIDIA Dynamo at that point, so that was released GTC last year. We looked at it as well around the same time as AI bricks. it definitely done a lot of what we wanted from a software perspective. At that point in time, we had NVIDIA GPUs in production. Yes, could have used it. I don't like tying myself to any hardware. In fact, that's just a long-term bet. I don't know whether TPUs or whatever are going. Like, good thing about vLLM, it can pick up support for all sorts of chips along the way, if you can end up making use of it. But again, going back to the big point, when we start to think about distributed compute, while I might have a massive cluster of NVIDIA GPUs for training workloads, batch workloads, that type of thing, if I'm doing edge sort of inferencing, I might have TPUs there, I don't know. So, not really knowing where this whole market was going at that point in time, you have to sort of prepare or be prepared to take on anything. And that was a large part of why we wanted to do it. Definitely love seeing the amount of open source software coming out of NVIDIA these days, but the community behind vLLM was just much stronger. That was a better bet for us at that point in time.
It is very explanation. May I could tell more about performance into the multi-agent setting, especially for the long horizon task with multi-tier conversation. You know, it is in a multi-agent setting, not single multi-agent setting, because in the research of the real deployment, it might deploy in a different multiple agent setting. So could you tell me the performance, how to accelerate the performance in this very high demand site? I really want to know.
I'll be honest, I've not spent a lot of time doing performance tuning yet. I've been mostly looking at it, just getting it working from what our core needs are, if I'm being honest. That's been a challenge. The multiple agent sort of MOE stuff, MOE was good fun actually. We got one customer using MOE model, llama, or Llama 4 Scout MOE that the customer was using. And anyone that's done any sort of capacity planning for infrastructure at one point in their life will know you've got a baseline level of calculations and you can sort of say, back napkin math, that's the ballpark we're going to be. MOE models brought in a sort of different piece of that. I'm looking forward to using llm-d. I know it's got a bit of scheduling support for the MOE models. I think that's what we'll probably look to use for that type of thing. But yeah, again, being completely honest, like any sort of software engineering thing, I do the performance tuning approach last. I want to make sure I've got something working before I go looking for the last 10%. Is that helpful?
Yes, thank you.
Awesome.
You talked about kind of the jump between vLLM and llm-d. I've got a rather eclectic mix of GPUs and DJ Sparks and then upgrading the server blades. At what point did you actually say, well, we kind of need to go llm-d instead of vLLM? Is there like a jumping point where you thought that has to happen at that point?
No, I mean, I'd say our environment isn't even completely heterogeneous. We've got our modules, brain's not working today. We've got a mixture of sort of training class GPUs like H200, that type of thing. We've got RTX 6000, Dell 40S. So we do have a bit of a mixture of accelerators from that perspective. We knew we were going to need something like llm-d. We're kind of hoping that AI bricks would initially do the job. We looked at Dynamo, obviously, and that's where the issue, man asked about why not Dynamo. Dynamo was released at that point. We looked at it like it does everything we sort of want from a software perspective, but at this point in time, it doesn't have the community behind it. It's a bit much to put all your eggs in one basket when something's only code. Bit different with Red Hat because they've got a track record of 25 years of being a sort of nurturing community of open source projects in the Linux community, the wider ecosystem. It's a bit more. There's a bit more trust between saying, here's Red Hat, they have been delivering quality open source software for 25 years, and you can absolutely bet your bottom dollar if it was put into production with Red Hat Enterprise Linux, it's still going to be around 10 years from now. It's that type of attitude. While we looked at Dynamo, we knew we were going to need something. Being perfectly honest, just kicked the can down the road a bit and decided, at this point in time, we've got one external customer using it, we've got about 4 internal users. That's enough for the sort of lazy, poor boy load balancing over a handful of sort of stateless vLLM instances at that point in time. again, not pretty, it was good enough. It goes against my better judgment as a software engineer, but again, being a startup, time pressures, everything else, not opposed to the judicious shortcut. No, but again, we knew from day one that we were going to have a load of different classes of accelerators and whatever they might be used for, whether it was edge locations, whether it was big training sites. There was always going to be a mixture for us. That's where having the sort of early market experience as a network connectivity provider to all of these GPU clouds gave us a lot of idea of what actually is possible here. So while it's a bit odd to be thinking at that stage at the beginning, it can be a bit helpful. Yeah. Anyone else? Awesome, thank you very much.